Okay, so here's the scanner. It comes in a case. You open the case. There's a scanner. It's the Go Scan 50. There's a cable to connect to the computer. It's pretty long, which is good. So basically it's a USB, so that just plugs into the laptop. Like that. And then this plugs into the back of the scanner. There's a little line at the top that orients with the white arrow. Pull that back and that clicks in. Okay. And then there's also a power cable, so it's not cordless. It requires power, so that means we'll need a generator if we're on a site. So that plugs into the same cord and then into some kind of power source. I see there's a blue light, so that's got power. And you can see the cord is pretty long. And then the next thing I'll show you is underneath here is the calibration pad, and there's some kind of a document stating when it was done and how accurate it is. So this should always be kept safe. So that one, you just open it up and do the calibration. So I'll do that calibration in another video, but that's basically
perfect. So we are connected.
Mm-hmm.
So the first object first little icon we see is that circle with those arrows all pointing inside that circle here.
Yeah.
So that's our calibration wizard. Has everyone here run through a calibration?
We did it yesterday, but I guess.
No. Okay.
Yeah,
let's run it through.
Okay.
So let's just grab the plate. Another recommendation about calibration: you can get away with not calibrating for like a few days only if you're in the same control environment.
So it's like if you're always in the same spot, scanning the same thing. That would do.
Same temperature, same relative humidity.
Like if we were to bring this on site somewhere,
Calibrate it.
calibrate it.
Wait 20 minutes
Okay.
so that the unit is acclimatized to your particular environment.
Yeah.
Go ahead and calibrate, and then do your scan.
But just like
Because there's a mix of plastic, steel, aluminum.
Right.
We use different materials to keep mount all those cameras in place with the systems.
Right.
And to get the maximum reliability, just make sure that everything's sort of expanded and set to whatever your ambient situation is.
Okay.
Cool. That's for ultimate maximum precision.
And do you know what the tolerance is? Like how cold you can use one of these things? Like
These, I'm not sure. Those, I'd say you could go down to the probably sub 10 degrees. I'd say to acclimatize quicker, the best possible scenario would be leave the lid open.
okay.
On the case. Don't take. So whoever wants to go ahead at a calibration,
Yeah, I can do it. So we just click on the.
click on that circle over there. That brings you to the wizard. And then I find these a little confusing, but basically you want to always point the center of the plate, the center of that white plate, and be at the right height and follow those, I guess, those level gauges. So you go down, 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 down. Okay, there we go. Started picking them up. Okay, so this guy and this guy.
Seemed like yesterday, we were going up and down and there was a square.
That's right, the square is supposed to show up. There we go. Okay. So the last one missing was our height. That's our height gauge, and we're always pointing the middle of the. Okay, so this one really is, you just move straight up.
Okay.
On other ones, it's like orbit around.
Right, like that one that's the tall, thin.
Yeah, you have to orbit around a little more, and it gives you a ghost. It's not just sliders like that, it's an actual ghost in 3D projected in the screen that tells you where in space you should hold the scanner
Oh, wow, okay.
in relation to the plate. So that's it.
Okay, so calibrating the scanner with the plate. So you go into calibration, you get this screen here. So this is basically the same as the pad, and this represents your movement of the scanner up and down, and then this is kind of the angle, like tip and yaw or whatever that's called. Okay, so basically I'll see a box, a white box that mimics this. I want it to be in the middle, and then I want to be following that bigger, so I pull it back, and I'm gonna score a bunch of times when it sees what it needs to see. Okay, so you start there. So I'm a little bit, there's the box. Need to get the box into the middle. Okay, so that did it. So now it's taking that information and it's done. Okay, that's it.
We're calibrated to this environment. The advantage of this one is fairly straightforward. You just move up. The minute we're done with calibration, we tuck the plate away, we put it back in its case. We don't want to drop it. We don't want anything bad to happen. And we don't use it as like a reference, if you will. Like if you have a small part that you can't put targets on, don't put it on that plate.
Okay.
Make yourself a separate targeted environment. Always treat that plate as sacred as you can.
Okay.
So we've done our calibration. The one right next to it, the little symbol right next to it with those 3 bars. So that is what we call a configuration, but it's also the shutter speed.
Okay.
Yeah, let's disable it just so we can go through the paces here. So again, normally automatic shutter should really be okay for you guys, but in the event that you are running into issues or you'd have a particular situation where, I'll give the extreme example, you'd have a checkers board where you have white and black or chess set, you know. In a case like that, you're gonna wanna do it in 2 shots. You know what I mean by it? So the black requires a long, intense light emission and open camera exposure time to get more data back. Black absorbs the light. We need to leave ourselves a chance and really open up those cameras for longer to let more information come back to the lens.
That explains what happened yesterday. Maybe.
Yeah.
The opposite end of the spectrum, I'm white, a lot of light comes back. I'm gonna be blinded. If I have a long exposure time, I'm gonna see too much, the camera's gonna see too much light.
Okay.
It's gonna sort of like literally be too blind.
Mm-hmm.
We need a lower shutter speed to filter out and make sure that we're grabbing what we need. So 2 extremes, white and black.
Mm-hmm.
Everything else obviously in between. The type of finish on the surface can also play a role. Bad situation, high gloss black.
Okay.
Because then the gloss bounces back the light, but you don't see the color, you don't see the black. So it's sort of like you need a high shutter speed to see the black, but then the gloss throws you off, especially with a white light scanner like that.
And what's the number, like what's a low shutter speed, what's a high shutter speed, like in terms of numbers?
See, I believe with this guy, the low is 1, so 1 millisecond.
Okay.
And the max is probably around 8.
So 1 for white and 8 for dark.
Yeah, pretty much.
Okay.
The default, I think we put it at 2, like just as a default starting point. That covers a lot of cases most of the time. Cause any kind of like light color or even like the gray of the walls here too is fine. You know, the stone over there, I don't know, maybe 3 ballpark, cause it's a nice light color.
Right.
Just the same.
Yeah.
Maybe you'd have to bump it up a bit because it's flat, it's not glossy, but we'll see.
Yeah. We'll see.
So like, let's say you have a stone that's like a beigey color, but there's a whole bunch of black staining on it. Will that affect that scan, or will you just
Yes.
get the white around it?
Well, what you're gonna end up, the symptom you're gonna have is you're gonna see that the scanner's gonna pick like the beige up really good, but where it's black, it's just not gonna grab anything.
So you need to do that in two parts
Yeah,
as well.
I would do is like, let's have the shutter speed for the beige,
Mhm.
and then let's capture everything we have to capture in beige.
Mhm.
When we're happy with that, we'll bump it up for the black. We won't see the
Okay.
beige, but we'll be picking up the black.
Okay, and then you just superimpose the two and it.
You don't superimpose anything.
Oh, okay.
You change it live as you're scanning,
Oh,
and
okay.
it's just that the scanner will end up seeing it.
Oh,
Oh,
I see.
okay.
You can change the shutter speed as you're scanning.
Yeah.
Okay.
Yeah, well, unfortunately, we can't do it directly on the device with this generation. You have to play with the slider like on the computer. But you can definitely play with that as you're scanning anyway. There's no issue there. So that's probably why. If you're in automatic shutter, the downside to that is that it keeps trying to compensate for both colors at the same time. So you end up in this vortex of it keeps chasing the shutter speed it's supposed to without ever really finding it. If you have a blended part, if you have something that's like, you know, those extremes together.
Yeah, we did a part yesterday, which was black, kind of glossy.
Yeah.
But
I had like a white base.
A white
so
base,
it was like,
So I kept trying to figure out
Yeah.
what's the shutter in between, what's going on, and you probably end up having a hard time.
It wasn't really capturing much, to be honest.
Yeah, because it kept jumping. It should be black. It should be white. It should be black. It should be white, and you
Right.
end up with that just vortex of nothing. It's just not seeing anything.
So we could go in here and change.
You
the
disable
slider.
automatic,
Yeah.
and then you say, okay, I'm going to do everything that's white, and then I'm going to do everything that's black
Right,
in the same scan, in the same instance,
yeah,
and you'll get your full. You just have to break it down a little bit.
right, sure, that makes sense.
And so I have a question. When you're scanning, you have your finger on the trigger.
Yeah.
You're going around and around and around. When you let your finger off the trigger, is that end of scan, or
No.
can you go back and do it
You
again?
can always pick up where you left
Yeah,
off.
okay.
Always.
Okay,
Always.
Good.
Up here to end the scan, I think, eh?
Yeah, but even at that, even if you press stop, you can always go back and continue. There's no, really when I'd say there's no going back is when you've exported the file.
Okay,
But if you're still in a session,
Yeah.
you can always go back,
good.
always do whatever needs to be done.
Nice, okay.
And it will, like, no matter where you hit it, like, no matter where you stop and then restart again, like, if it's different places, it's.
It depends on how you're scanning, what your conditions are.
Okay.
I'll get there quickly.
Okay.
It depends if you're using targets or not,
Yeah.
for one, and it depends where your targets are. Are your targets on the
You can
part?
see it from this side and that side, or, yeah,
Well, are your targets on the part or in the environment?
okay.
That's another thing. And yes, you can always pick up where you left off, as long as, depending on the circumstance, you did not move the part.
Okay.
Oh, like rotate and.
That's right. If your targets are only on the part, you can move it all you want.
Right,
If your targets are the environment, your part is sacred, it cannot move.
Right.
Until you're fully satisfied with your scan, and then if you wanna get the other side of it to get the whole thing. If I'm happy with scan number 1, then I'll flip it over in my targeted environment. And then I'll do scan number 2, align them together, stitch them up, and have my solid part as a whole. We'll go through all that,
Okay.
but just depending on the circumstance. This guy is a little sensitive. I find he loses track a little easy without targets.
okay,
But if you have targets, you've definitely made your life a lot easier.
okay.
You don't necessarily need a ton. You just need some for it to grab and
To reference.
Yeah.
Does it, like a part like this one, this stone on the end here, is it best to have a target on every face, if you're scanning every face?
It would help.
Okay,
Even on the bigger faces, I'd say trying to have 2 randomly placed. The key to the target placement on the part is randomness.
Okay.
You want, it's because basically it's triangulating. So it needs to see something different on every face to understand that that is different from something else. Right? If I'm scanning, like the worst example is if I'm scanning this table here, what makes this different from that? Right now, nothing. Whether if I'm looking at it here or I'm looking at it here, it's exactly the same thing, same color, same pattern, same everything. How does the scanner know where it is in space if it's looking at the same thing over and over again?
So is the scanner like, what's the scanner? Is it actually measuring distances?
Basically, it's measuring the deflection of the light pattern.
Okay, so it's not a laser, it's just light.
This one is not a laser. This
Okay.
guy is white light. And so it's big. Another way of saying it there, it's projecting a QR code and it's measuring the difference it's seeing in the QR code as you're hovering over the different objects. So as the QR code, if you will, distorts, okay, it's measuring what's the distortion in space in relation to that and mapping out the object. Does that make sense?
I guess so, yeah, yeah, okay.
So it comes with advantages, but also certain vulnerabilities. The big advantage is you're able to capture the color.
Right.
When you're projecting the white light, you can grab the RGB spectrum. If you have a laser product, you're not going to get that. But you're going to get a more reliable laser cross pattern, and you're going to measure the difference in that cross pattern. But you're going to need targets. You're not, like, the geometry alone is not going to do it. You're going to be having to put targets on your things or in your environment.
So does this scanner, like, if I scan that block, does the model or the mesh that's created, does it have dimension?
Yes.
Size?
Yes.
It's-
You can measure
Yeah.
directly here. I think we should be able to. Let's see, can we with this?
Oh, yeah, I found a measure somewhere. Where was it?
If not, it's in VX model.
Yeah,
If it's not here, it's in VX model.
I think it was.
Yeah, okay.
Maybe like caliper and stuff like that.
There's caliper.
Yeah,
calipers.
Caliper, distance, angle.
Okay.
Yeah.
You can, but yeah, you can measure.
Because I wasn't sure if you had to, like, once we bring it into our software for the saws, whether you have to geo-reference it so that it's
That
scaled
depends.
or whatever.
We'll get there.
We'll get there, yeah.
We'll get there.
Okay.
But
All right, so
there's a few things there that yes, possibly. But what does your software recognize? What file format does your cutting program recognize? And we'll work from there.
okay.
It was that same file.
STL or something?
Is that what the file is? Yeah.
Because if it uses STL, I'm surprised. And
That's what we import, yeah.
that means it's a fairly advanced cutting software to be able to work with STLs. That's pretty good.
Yeah.
Okay, so to come back to our shutter speed over here, the other option is to get maybe that perfect result on the part that's, you know, a funky color or something that we're not sure of. We go into this menu and we grab the part that it is we're interested in scanning.
Okay.
And then we're gonna point the scanner specifically to this color of the surface we're trying to acquire. And the algorithm is gonna find the best shutter speed for us.
Oh, nice.
Okay, so as an example, we'll point that block over there. Doesn't mean that's what we're really gonna scan, but just to illustrate the process. I'm not interested in the table, I really want the block. So I'm gonna hold the scanner in front of, you know, basically my zone of interest. And now I'm gonna ask someone to hit auto adjust. There we go. So we see how the slider is moving. Okay, so at the distance I'm at, the table might be throwing me off a bit. I am getting part of the table with my part, but basically, you know, it says on the bottom, so black, nothing's picked up. Gray, I'm underexposed, I should let more light in. Yellow, I'm bang on, not too much, not enough. red, I'm blind, there's too much light coming back. So yeah, and see, now that's 3. That does make sense for the,
You said 3, didn't you?
Yeah.
You said
yeah, that makes sense, that's a value that makes sense for the block. Now, I guess maybe the table's kind of thrown off with the red there, but, so that's a place to start. If for whatever reason, once again, you know, it's not picking it up, it's not seeing anything, you can always play with the slider.
Right. Do a couple
and-
scans. Yeah.
And, you know, I still think that 90% of the time, automatic shutter will work
Okay.
for you guys. So we can okay out of that. Oh, one more thing. You can save the preset if you want. There. So example 3, right? And this is whatever, you have a code, you have a designation for this kind of stone, this kind of color. Well, you could rename it stone whatever. And then next time around, 6 months from now, the next time you're scanning the same thing, you go back in your presets. And then instead of going back and trying to figure out what shutter speed I was, oh, I have various sandstone. So that's my profile. I'll just click and I'm ready to go.
Oh, cool.
So yeah, so that's it for real for the configuration, aka shutter speed. I personally think they should rename that shutter, but
What, this one I just put in Bria?
yeah, and it went back up to 3.03. Factory default is 2.
And you wanted me to rename what?
No, you just did. You just created the.
Yeah, no, okay.
Yeah, that's fine. I just said just say okay and exit the wizard.
Okay.
All I was saying is instead of being configuration, it should be called shutter.
Oh, I see.
That's all.
Right.
Good. So that takes care of those initial settings for our acquisition, our data acquisition, for anything like camera wise. Then we have the positioning parameters. So this is where we decide how we're going to track, what method we want to use to track basically our object, what we're trying to scan. So we have targets only, which is targets required. One more thing we have is semi-rigid positioning. What semi-rigid positioning is mainly for the human body or like your dog or your pet, something that's not perfectly still, something that breathes, that has micro movement in it.
Okay.
So that's in your case. You're perfectly rigid. Then you have use natural features. That's using basically, today we call that geometry positioning, which basically means we're using the texture, we're using the shape of the part itself to map it in space and use that as a positioning element, as a way to position our part. And then we have show positioning status. What that one does, that can be checked with any other option you're using, and that'll give you a warning on the lower right hand side of the screen to let you know that the scanner's lost track, or you move this way, or there's something going on that you've lost position. So it could be interesting to have it checked, depending on the situation. And then underneath we have, well, obviously automatic shutter, and underneath we have capture texture. So that's where, right now, if that is checked, it's gonna get the color. Texture really means like surface color.
Okay.
So if we don't need it, I'd say don't check it, just to help the process along.
Okay.
So we got our shutter speed. We have show positioning status. I would say, can you use natural features? You can't do both, and you can't do.
Seems like I can't.
Okay, then it should do it on its own. If you can't check it,
Okay.
we should be able to start scanning. So again, we can scan without targets, but we have to be slower. We have to be more polite about it, and we have to be careful with our movements. Really be sure it doesn't lose tracking.
So
Slow, steady, and another thing too, we describe that as the spider web technique. It's you want to start like here, say you'd want to start at a place where there's a lot of distinctive features. It has a lot of distinctive sides and edges to latch onto. And then you want to move away from that as you start scanning, but you want to go back to your initial position and then go in a different direction. But always come back to the center of where you started. That way it sort of it helps with the volumetric accuracy a little bit, but mainly it helps with the tracking. You're always going back to a well-known mapped position.
Okay.
And then the more data you grab, the more distinctive features there are, the easier it is for the scanner to pick it up. Like this isn't so bad because we have a fair amount of edges here, and we even have like the maple leaf inside. It's got a bunch of little ribs and features and edges and stuff. That's actually not too bad for not using targets because it has distinctive things to grab onto.
I see, okay.
There is a fair amount of uniqueness. There's also like these little scratches here that might help a little bit too in making it unique. Each face has to be as unique as possible. The table, a nice flat surface that's even everywhere, that's a lot harder. Really makes your life easier if you stick random targets on it.
On the flat surface?
Yeah, on the flat surface. That'll really, really help. So that pretty much covers the hardware panel side, if you will, with the shutter speed and the different adjustments. Any questions so far?
So that's all the controls we have
Yeah.
on the program for
And
the actual
that, yeah, exactly. That really affects like the acquisition, if you will, of our handheld itself.
Okay.
Any questions? Is this enlightened a little bit from where you were?
Yeah,
Yeah,
this is good. I just have a couple quick
Sure.
questions. Just when you were saying the table was giving you kind of issues when we were just doing the
Mm-hmm.
calibrating, is that because like the light is reflecting off the table onto the?
That could very well be. There's a bit more of a glossiness on the table than there is on the stone. The stone is a really dull, flat surface. The table is sort of satin. That might throw off a little bit. And, if I'm holding it like this, as opposed to maybe holding it dead on, that may have played a role a little bit too.
Okay. And then if we were to like put our stones on like a Lazy Susan
Yes.
with targets,
Yes.
is like the ideal color for that would be
Black.
Black,
Flat black.
flat black.
Flat black with a bunch of targets on it. That way, the scanner is seeing the targets, but your shutter speed is set at like 3, so it's not even really picking up the Susan. It's seeing the targets just fine, but it's not seeing your environment. Well, it's only seeing the targets, really. So that's the best possible combination because your shutter speed is set for the sandstone that you're interested in. That's what you really want to grab. And then you're neglecting your Lazy Susan, that's that much less you need to trim to take off after.
Right.
We can still clean up the scans just fine, get rid of our background and all that. We're about to get there. I'll show you all the works that way. But that's really the best possible outcome is if you can sort of off the bat neglect your environment and just get your part of concern. That's just less trouble. It streamlines the process that much better. But yeah, definitely a black Lazy Susan, flat with targets on it. We have them in the office with the very first things we recommend to get. Because then you can, when you find your angle, you just go ahead and turn it with your finger. The part doesn't move in relation to the Susan,
Right.
Okay.
so you're good to go.
So it's essentially like having a target on your part because it's on
Yep.
the Susan that's moving at the same.
That's right. Your piece of brick is not going to move in relation to the Susan.
Yeah. Yeah. Okay.
But if you put the targets on the stone itself, then you can turn the stone 90 degrees and everything while you're scanning. It wouldn't matter. Just the environment would end up flipping and doing weird things, but that doesn't matter because what you're interested in again is the stone. We'll get there.
Yeah.
We'll get there.
A lot of times our pieces will be bigger or actually the building. So yeah, putting the targets on the
It's going to be
building is the only option really.
yeah.
Yeah. Okay.
Yeah. So does that wrap up?
Yeah. Yep. That's pretty clear.
Yeah, I'm okay.
Perfect. So we'll move over to the left-hand side. So we see that we have the navigation panel where we have our scan 1 with our texture. Basically, it's just like similar to any CAD software that like different scans, different positioning elements, clipping planes, stuff like that. They're all going to be populated in that list as you go down. They're all just going to show up. You can change them, you can edit them, you can play with them as they appear.
Okay.
Then underneath that we have the scan details. Yeah, you can move that up. Yeah, if you want, you can just yeah, exactly. There we go. So scan details, that's just giving you a live reading on what's going on with the device. It's fun to see in the beginning, but you got so much other stuff going on that you're not going to pay attention to that anyway.
This is
when you're
specific to
scanning.
this scan, right?
Yes, right now, yes, because we only have one scan and it's highlighted.
Right.
So that's going to be, and that only like the scan details, that really only shows up as you're holding the trigger scanning. When you stop, it just sort of stays static and gives you the latest number. So there you'll have like the number of triangles, the vertices, and the targets that it's seen.
Right. Okay.
Fun in the beginning, but won't be too long. You don't pay much attention to it. You'd rather have the scan parameters visible instead, which is where I'm going to next. So then we have in our scan parameters resolution. So one important thing to note, high resolution does not mean high accuracy. They are two separate things. The data that's been acquired, like it's been acquired the same way. There's no difference in how the scanner in reality maps the points in space. What it does change is how many points the scanner is getting. The more points I have, the crisper my scan can be. The more details, the more sharp edges I'm going to get, obviously to a certain extent. So whether I scan, coarsely at a lower resolution, which means a higher number here, that doesn't mean that what I've acquired is not precise. It just means it's not sharp. It's not necessarily crisp to the level I need it to.
Right.
I need it to be.
Right.
Again, you have fairly straightforward objects here. So that shouldn't be a problem. A rule of thumb we say for resolution, to set the proper resolution in accordance to what it is I'm scanning, what's of interest to me. I'm going to look at the part itself. So what do I want to acquire? I'm going to look at the smallest geometrical feature on that part. So in most cases, it's like a threaded hole. It's a hole on a mechanical part, a steel part, whatever. In this case here, maybe it's like, the width of the stem of the maple leaf on the front of that. I'll take the smallest feature size, whether it be a width or whatever, and I'm going to divide it by 6. That's my best starting point to get the nice resolution, to get the crispiness I would need to, whether it be reverse engineer, inspect, replicate, duplicate a surface of some sort. That's really the starting point we suggest. You can go higher, lower, depending on the circumstance. Yeah, with this guy, you hit a wall at 0.5.
0.5 millimeters. So so that stem is probably like 2 mils, 3 mils,
Oh, yeah, easy.
4 mils.
I'm thinking more like 4 easy.
Divided by 6 is gonna be less than 1 anyways.
Yeah.
Half or something, it's almost at the maximum.
Yeah, well, it's in between 1 and 0.5, 0.8 maybe, so
4 divided by 6, yeah,
yeah,
okay.
not like that. So, yeah, and again, I think this is like one of the smaller features for you guys, unless you have.
Yeah, it's probably maybe some of the sculptural stuff, you might have like a little indent in your eye.
Yeah, you're much smaller than that.
Parts of your ear.
Oh, right, okay. Yeah, in that case.
Strands of hair even, you know.
Oh, right, okay. In the case of a statue, I'd say bring that down to 0.5, because that's it's as low as you can
As
go.
low as you can go, yeah, okay.
For like, a nice big brick over there, you could go 2, because
There's nothing, yeah.
unless you really need an edge of some sort of funky edge, but it's really straightforward as a shape. There's
Yeah,
no.
And further to that, like, we can't cut
Yeah.
cut the part any more accurate than
Right,
2 or 3 mils anyways, so.
right. So you're comfortable within,
Yeah.
you're well within your tolerance of fabrication
Yeah.
and okay. Good, so that's the resolution, and then we have underneath fill positioning targets. That, I always recommend you leave that checked. What it's basically gonna do is fill underneath the targets. Where there's a target on your part, obviously the scanner is not seeing underneath that target. So it's making the best average of the surfaces around the target and just filling it tangent to all that underneath it. So that's why we strongly recommend never put targets close to an edge, a chamfer, a radius. Always try to put it as far away from distinctive sharp features and where it's constant. That way it's easier for it to fill after and be a nice constant part. If I put if I fold the target in half, if I fold it over an edge, I'm distorting the target too much. It's not even gonna be picked up by the scanner. I've actually altered its shape. It's no longer an ellipse anymore. It's just this weird, unrecognizable feature to the algorithm. If I put a target too close to an edge, I'll end up with an artificial bulge, because the algorithm's going to try to match a 90-degree surface to the other one. We could test it later. It'll make sense. We could purposely put targets close to an edge, and you'll see what happens.
Is there anything special about the targets, or they're just uniform, whatever? Like if you had something that was made out of something that looked like targets, you wouldn't want to put targets on it because it would just confuse it, right? Like, I don't know if that makes sense.
No, I don't think so. Unless you had something that was really full of like dark rings with a white center.
Yeah. It wouldn't, okay.
It wouldn't confuse, because the algorithm, even like the target itself, it's not the target it's seeing, it's the difference between the white and the black.
Okay.
That's why you'll notice even like when you take targets out of the box, the white circles are not necessarily always perfectly centered with the black one.
Yeah.
You can have a little bit of offness in those targets.
Okay.
What the algorithm is really looking for is the difference between the center and the white and the outer black. That's what makes it a target.
Right. So you could make your own targets. Like if we ran out of targets, we could just have. They'd have
Not
to be really
really.
uniform.
Not really. Well, unless you have a really good way of replicating that with the kind of shininess.
Oh, we have a print shop upstairs. Oh yeah, we could. Well, I'm not saying we're gonna do it. I guess my question was, do we need to use targets, or could we use different things that look like targets?
We always say you have to use our targets
Yeah.
if we guarantee the result. We've
Right.
had some customers, they buy like boxes of targets on Amazon, but sometimes they find they don't get necessarily a super good result, or it loses tracking a little bit or whatever.
Yeah.
Yes, they are cheaper, but and if you're not going to use that, well, we won't guarantee any kind of result. In your case, if you have a really good print shop, I'd say I'd be really curious. I'd want to try it. In your shoes, I think I would want to try it just to see what happens at the minimum. You're not in aerospace. Doesn't matter.
Yeah.
So
No,
if you
I'm
can
not trying
try
to save
it,
money or anything. I'm just wondering if that's the case, like whether it has to be specifically those targets or whether
Because
it's just a geometric shape that it's gonna pick up.
Normally, it's really those specific
Okay.
targets, and even those targets there, I like to say we have different flavors. I brought some with me, I'm not sure what they are, but there's different kinds. You have normal reflectivity, low tack, so they're easy to take off. Normal high tack, if maybe you guys would want high tack because you
think
have
that's
such
what we have.
porous materials. And then we also have high reflective.
Okay.
So we have high reflective that helps. They're mandatory with certain products that we sell for them to be seen better from far away. When we sell you a scanner that works a meter away from the part, we put high reflective targets mandatory.
Okay.
Your case doesn't matter as long as you have 6 millimeter. You should be just fine. Unless you tell me like you're using it at night or at sundown on the side of the building, I don't see why you
Okay.
would
Cool.
need high reflective.
Yep.
Normal should do just fine.
Just before we get too far, right, so another thing we have thought of scanning is something flat.
Mm-hmm.
Is anything that you've discussed here, resolution?
Well, in a case like that, I think just to play it safe. Oh, well, no, not even. All you're really interested in is the 2D profile, right?
Yeah.
You wouldn't care about the thickness.
No, not at all. A lot of times that's how we work. Like we'll take a profile off of a stone that we need to
Right.
rebuild. We'll extrude it in our program based on the measurements. But one of the challenges is replicating this geometry. This is a simple one, but in some cases,
Yeah, I hear you.
This is like an ellipsoid or made of like
Yeah.
circles.
It's super compound or whatever.
and you end
Yeah.
up making something that doesn't match this. If you could just like scan this.
Yeah. The one thing I would say, I think though, because I'm torn, I'd say I wouldn't want necessarily to like have a high resolution because it's flat.
Yeah.
All that's important is the edge.
Correct.
What I would try to do is make sure to put it on a contrasting situation. That's probably not bad the way it sits now. This is all nice and white on a darkish gray surface. So we should be able to make out the edge pretty good
Right.
around the outside. That'd be worth trying later. I'd be curious to try it like that on the table and see what happens.
And yeah, like in some cases, like these are clear. You know, this is white. so-
Clear is going to be a problem.
Yeah.
Clear is really going to be a problem with this scanner. It's with the white light. It's going to be. I'd say if you can, definitely try to spread some turtle wax, cover it with white paper,
Yeah,
or
or
put white paper underneath it, or
I mean, the translucence is good when you're on site because you can see.
Yeah.
better. But you can always just trace this into another piece of paper
yeah,
because it doesn't matter that it's this. This is handy because
it's
lasts.
super handy for you on site. I get that.
And-
Yeah,
And for us to use it, like this is from 4 years ago. We might use it this year.
right.
So that's good to keep, but for the scanning purpose, we could just trace it and cut it out of anything.
Maybe if you find like a color that works really good.
Yeah.
Example, you have a background where like, okay, it's always this gray background, and I find that, I'm just making this up, but like, somehow orange, like bright orange works really good shutter speed wise or something, then you just use your white, your orange on top of your black, and you'll always pick up the nice contours.
Just something contrasty.
Definitely.
Yeah.
You definitely want to play with contrast extremes, and then you set the shutter speed for one of those extremes.
Right, so it's white. It's got a high contrast to black.
You're setting,
It's got
and
high
you
reflectivity.
undo automatic. You have to undo automatic in a situation like that,
Right.
because otherwise you'll end up not scanning anything really.
Yeah.
So you set one value high, and then it doesn't pick up, it doesn't see the other one, and you get your nice contour.
So it doesn't matter if you set it to 1 or 8, all you want is that contrast just to pick up
That's
And
right.
if
You
it-
make sure you don't have the automatic, and you just want to pick one or the other.
Okay. Makes sense.
That's how I would definitely try.
Okay.
And if it, for whatever reason, there's too many obstacles or something, I would bring down the resolution all the way down to 0.5, and that way I'd get maybe a chance at getting the little thickness of the paper around the whatever surface that it's on. Then underneath, we also have optimize accuracy of the boundaries. That one can also be checked. It'll help. Basically, it's going to just help crisp out edges
Okay.
of the scan. Because this is a little older, we have to play with these sliders, but I actually kind of prefer this to what we have now, which is what we call smart resolution, because that's more of a black box that the algorithm figures it out for us. This gives us a little more control over here. So we have optimize scan mesh, and then we have decimate scan mesh. Then we have autofill holes, remove isolated patches. I'll start from the bottom. The remove isolated patches, I wouldn't be too big on that feature, because depending on the threshold you set, it's going to get rid of information, or it's not going to show you information. I would rather have everything, even if there's isolated patches floating around, and just clean them up after, but make sure I clean it up my way. And I keep what I want to keep. Maybe there is something floating that I want to keep for a spatial reference or something for me somehow. I want to have full control on what's the data I'm keeping, what's the data I'm getting rid of. Personal preference, you could play with that and decide if, whatever works. And then we have autofill holes. Again, that one I would kind of relatively stay away from, because you're letting the algorithm fill the holes for you in what it thinks it's the best fill, as opposed to you manually filling or tickling it along the way it's supposed to be filled. Sometimes it'll create bulges, it'll fill something a certain way, but it's not that way. Physically the part in front of you is not filled that way. So you go and bridge and do some stuff to fill it the way it's supposed to. Again, play around with those and see what they do, but those are the two I would recommend leaving off, just to have that much more control on the data. To the opposite end, those two sliders there, they sort of allow you to have your cake and eat it too. Decimate, basically what it's going to do is make the triangles as big as possible. So the bigger the triangle, the less amount of triangles I have in my file. The smaller my file size, the easier it is to manage in whatever other software, whatever other treatment I'm doing to that file after. But it will come at the compromise depending on quality or features or stuff like that. If I make bigger triangles, I have not as crisp definition anymore.
So how does the
That's where the
resolution-
optimized one comes in. Optimized scan mesh is going to make things crisper. So by playing with by maxing out those two sliders at the same time up top, I end up with the most decimated surfaces where they're nice, flat, and even, and it doesn't matter whether I have a lot of triangles or not.
Yeah.
Do I need a bunch of triangles to define this flat face? No. I need a bunch of small triangles to define those edges.
Okay, so we can do both.
So it can do both. By maxing out those two sliders, I get the nice enhanced edge with more triangles, so that gives me a crisper edge. But at the same time, I'm eliminating a bunch of small triangles on my nice flat even surface that it really doesn't matter.
So do we just keep those up at 100 all the time?
I would try that. I would leave those like that.
Yeah.
Might increase processing time a little bit,
Yeah.
but kind of gives you the best of both worlds.
Is there a way to set those as defaults?
Unfortunately, I don't think so. I think every session you're just gonna have to slide those up. Or you could see maybe 50-50. You know, you can play around with those, but at least this allows you, basically this is smart resolution. It's the smart resolution we have today. It's really making the best of making big triangles where we need them, small ones where we need them.
So we scanned this guy yesterday, and I noticed that it looked like the edges weren't scanning for some reason. Is that optimize accuracy of boundaries? Or?
That might help.
Okay.
That would help. And when you say not scanning, you mean that like it just wasn't showing up?
Yeah, the info
It
wasn't
was-
there. It didn't
was
look
like-
like it was there. Like we maybe had to fill it or something.
Spacey and wavy.
Yeah.
Yeah, they weren't sharp. Sure.
It wasn't bringing through
Okay, but
the
it
color.
depends.
It was,
Like it wasn't sharp or it just wasn't there. There's a difference for me there.
I think that it was like the part was colored except for this was like blue or green or something. Do you remember that? It was like a
That
not
doesn't
the-
matter. That's
Okay.
the texture. That's the camera freaking out probably because of the angle and the light.
Okay.
It's not able to capture the color of the edge maybe quite properly. If you don't care about the color
Mhm.
right off the bat, that doesn't matter.
Mhm.
And as long as it's not black, like a missing hole, like a hole, like something that's not there. If it's rough, it's coarse, okay, we've just played around with the accuracy of boundaries and those two sliders. Like, did you play with those yesterday?
No.
No.
Maybe 0.
So
Yeah.
that'll play a big role because the way you had it set up yesterday was probably you had 2 millimeters
Mm-hmm.
and it was freaking out at 2 millimeters. It's not able to give you a crisp edge
Mm-hmm.
because all the triangles are the same size everywhere
Mm-hmm.
on the part. So it only has 2 millimeter, when I say this, I explain this. It only has like the 2 millimeter size triangles to define that edge.
Mm-hmm.
So yes, it's gonna give you something, but it's gonna be choppy. It's not gonna be clean, or it's not gonna be as clean as 0.5.
So when you set the resolution to 2, the maximum size of the triangle, if it's all decimated, is 2. And then optimize is gonna be less than that? How does that, how does the scan mesh, like, get that number?
I hear you. I'm not 100% sure, and what I mean by that is, I think if you're down to 0.5, your smallest triangle is going to be 0.5. Your optimized scan mesh is going to make those nice, and it's going to decimate up to whatever it needs to on the flat surfaces.
Oh, okay, so the resolution is not.
I'm just not 100% sure. It's something we could try later today. I just don't know by heart if it works the other way, where if you set it at 2 and you say and optimize, it can go down to 0.5.
Right,
You know what I mean?
yes.
I'm not sure if it works both ways.
Mm-hmm. So better to put it at 0.5.
If
Or-
you have to.
if
If
we
you
have
have
to,
to.
right.
Because yes, 0.5 is nice, it's sharp, it's clean, but you're also spending more time and more processing power acquiring more data on your part. So there's still a balance to be had there. What do I really need?
Right. A piece like this, is 2 reasonable? Like, is 2 gonna capture those edges, or could you go higher? Because most of that's flat, it's just the edge and the leaf.
Again, I think 2 would do it, and the reason I say that is, do I really need the edge if I have the face in the face? I mean, if I'm gonna replicate this anyway, I'm just gonna cut, or for lack of a better word, machine my faces, and I'm still gonna get that corner out of my replicated machine.
Because we
I'm
have to
still
do
gonna-
that anyways,
You
right?
have to do the processing after, yeah.
Like we
Well,
have
yeah,
to
you-
in the alignment or whatever, right?
Yeah,
Or the entities and.
first we can clean, then we can extract the entities.
Mm-hmm.
Right.
And depending on the situation, if I'm gonna reverse engineer this in SolidWorks or whatever other CAD software, it doesn't matter to me whether those edges are crisp or not. I have all the faces and I know that they all
Intersect.
intersect themselves perfectly in CAD anyway.
Yeah. Okay.
In all our cases, that'll be pretty much
So,
the
I mean,
situation.
Okay, the edge is sloppy.
Yeah.
You know, not really gonna change a whole lot. Of course, depending on my workflow. If I wanna 3D print this, yes, maybe I should spend more time making sure those edges are clean, because when I put it on the slicer with the STL, I want a nice clean edge. And if I'm gonna sand cast it, or I'm just throwing stuff out there as a,
Yep.
but you know, so that's different. And again, even if I were inspecting it, probably wouldn't matter, because in my inspection program, I'd want to know what's the distance here, what's the distance here, what's the distance here. Would I really care about the edges? Not necessarily.
Okay.
So we've gone through our settings. We've gone through like what those sliders do, the resolution. I think at this point it's time to just pick a part that we would like to scan and talk about how we want to set up the environment and because we have basically 2 to 3 different workflows, ways of doing it.
Okay, sure. Well,
So,
we'll just start with that, yeah.
Start with that. Perfect. So we'll set ourselves up comfortable on the corner here where we
Yeah.
can go around.